Hey guys, it's Mr. Win, and we're going to talk about Unit 4, Section 7, Inverse Variation. Alright, so our essential question, how do I solve inverse variation? So we're going to talk about how do we solve for inverse variation, how would we write the equations, and what do we do when we get the word inverse variation. Now, variation just means how things change, right? There's difference, right? So how things change, and inverse means the opposite. So when you talk about inverse variation, we're talking about things changing in the opposite direction. So here's the formula for it. Y equals k over x. And k stands for a constant, whatever it might be, okay? So if I were to solve for k, just know that if I were to solve for k, you would have to multiply both sides by x. So really, k is just going to be x times your y. Okay? That's always how you get your constant. And I'll show you what we do when we actually solve problems. And we'll have to use that. But just say, for an example, if I had an equation where it's just y equals, let's say, a constant of, who knows, like 2. Okay? So if our k was 2, it'd be 2 over x. All right? And let's just do a table real quick. So if I have x and y, let's say I had 1. If I plug in 1 for x, right, it would just be, would be 2 over 1. So that means your y would just be 2, okay? Now if I use the example 2, right, and if I plug in 2 instead, so let's plug in a 2 for the x, right, it would be 2 over 2. So now we have a 1. Look how it's decreasing, right? So basically, from here to here, I multiplied by 2 to get that number, right? But then over here, I had to divide by 2. Isn't that doing the opposite? You see how there's an inverse variation? So I can keep going on. Let's say the number, like 4, right? So if I plug in a 4 here, it'd be 2 over 4. That'd be 1/2. Then at 4 would be 1/2. So again, to get from 2 to the 1/2, I would have had to divide by 4, right? And then here, to get to that 4, I would have had to multiply by 4. So see the relation where to get to those numbers, right? It's varying, it's changing by multiplying one side, but the other side is dividing, right? They're inverse, okay? That's kind of what happens, right? These are inverse variations. So let's talk about a couple examples. Here's something you might see. If y varies inversely, right, varies inversely, that's our key word, right, as x, and y equals 4 when x equals 2, write the inverse variation equation. So we're just writing the equation. We need the equation y equals k over x. Well, I know k is going to be your x times y. So in this case, k would just be 2 times 4. K is just 8. So when I use this equation, it would just be 8 over x. And those look like the rational expressions we've been talking about, right? So see those fractions, right? We got an expression, we got the x on the bottom. So that is a rational expression. Inverse variations are rational expressions, okay? So how about example 2? All right. I want you to take a second, pause the video here. Try this one on your own, okay? I don't think it's too hard, but find out k and then write your equation. So I'll give you a second and see how we did. Okay, hopefully we paused. But if you're back, we know that k is going to be your x times your y. So in this case, k would just be 3 times 2, which is 6. So when I write the equation, y equals 6 over x. Did we do it right? Awesome, hopefully. All right, so let's look at a real life example, okay? Oh, I gotta sketch the graph. Okay, so if y varies inversely, I didn't read the full problem, apologize, but we want to sketch the graph too. So if I have y equals 6 over x, I know that your a is going to be 6, your h is going to be 0, your k is going to be 0 as well, correct? So if I were to sketch this graph, right, we have our asymptotes at 0, and we have the other asymptote at 0. our graph would look like where A is 6. So I'm going to go over to 6. 1, 2, 3, 4, 5, 6. And up 1. And the other part, 1, 2, 3, 4, 5, 6 over 1. So remember, we're just graphing the inverse function now. Draw your curve. It would look something like that. So notice it is a rational expression, right? Do the same for your other side. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. If I draw my points, 1 over from the 6, you've got your rational expression function. You have your hyperbola. Okay, just like that. So your graphs of these inverse variations are just the same as your rational expressions. So notice how they are, again, rational expressions. All right, what if I want to do example 3 here? We got a real life problem, right? How does this relate to us? Well, look at this. Look at the situation here. A group of friends want to host a party at a ballroom downtown, okay? That happens, a birthday, quinceanera, whatever, right? They want to host a party at a ballroom downtown. The price per person of renting the ballroom varies inversely with the number of people renting it. So it varies inversely. Now, that makes sense, right? The total cost of renting that ballroom may be a certain amount, but the more people that are spending the money, the price would go down, right? So it's inversing. So the more people you have, the less it costs, right? It goes down. They're very inversely, right? You increase people, you decrease the amount of cost per person. All right, that's how it relates to us in the real world. Well, let's do this example. If it costs $45 per person, if 12 people rent the hotel, that ballroom, about how much will it cost per person if 30 people rent it? So let's write our equation. We know it has to be y equals k over x, correct? So if I know it's going to cost us 45, so that would be your y, that's your dependent variable, if 12 people rent it, and x is 12x, right? That's just saying like a point is 1245. If I multiply those numbers, I can get my k. So what would 12 times 45 be? It would be 5 times 2. What would be? Let's see, 12 times 45, 5 times 2, 10, 5 times 1 is 5, 6, carry the 0, 8, 4, that would be $540. Okay, so we know our equation is going to be y equals 540 over x. How would I find out if 30 people want to rent that? Well, 30 is in terms of y, or no, excuse me, x, so just plug in 30. So y equals 540 over 30. And if I try to divide that, just going to do the math to the side here. You've got 30, that's one time. That's going to be 16. 5, that'd be 150. Bring it down to 100. 0.3, that'd be 90. Bring it down to 133. So, and it could go on, but roughly $15.33 per person. All right? So notice, like if I had a table, it did vary inversely, right? If you only have 12 people, that was about 45 per person. If now you have 30 people, right? Only about 15.33, right? Makes sense. It's varying, right? This is increasing, right? From here to here, it's going up. From here to here, it's going down. Inverse variation. All right, and that's about it. Thanks.